Howdy and welcome back. We'll begin today's lesson with a brief review of memory allocation. In doing so, I'd like to first go ahead and review the anatomy of our programs in memory. So recall that when we launch our program, the operating system is going to provide it with a chunk of memory, and that this chunk of memory will be partitioned into a couple of different sections. One section will be the code or static region. This will store program code along with any global and static variables that have been declared within our program. The next section is going to be the free store, which is also known as the heap. Dynamically allocated objects will reside here. The free store will grow towards the stack, which resides at the opposing end of the program's address space. We introduce the stack as the mechanism to store automatic variables within our program, with specific focus on the parameters of our functions as well as any local variables declared and defined within. We went through kind of the motions as to how activation records can be pushed to and removed from the stack, and how this would actually perform the allocation of memory to these automatic variables and then deallocate them once the function has returned. Up until this point, we've used the stack exclusively to store things within our program. In the last lesson, we began observing some limitations of doing so. For instance, if we wanted to store a collection of data in an array on the stack, we had to know how to allocate that array at compile time. And this left us with few options. Let's say we were reading data from a file and we weren't sure how many maybe integer objects we were going to read, but we wanted to store them in an array. Well, we could have allocated, say, a huge array, potentially wasting memory within our program, or we could have been more conservative and allocated a smaller sized array and potentially not have enough space to store everything within our files. So the question became, how could we somehow create objects to store such data at runtime? That is, as we're reading in a file, how could we have an array that could resize dynamically to store all of the data within that file, provided again that it fits within the chunk of memory given to us by the operating system. Now, the other thing we saw that could happen is that if we created an object or compound object within a function, the stack would automatically deallocate space for that object once the function returned. The example we gave in the previous lesson was essentially having some sort of function that was responsible for reading data in from a file and placing that data into an array. Because that array was on the stack, when the function returned, the space would be deallocated for that array and the data would no longer be stored within our program. So the question then became, okay, well, how could we somehow create objects that we could control the lifetime of? What if we wanted to create an array populated with some data that maybe we read somehow at runtime, and we wanted that array to stick around until we no longer needed it. And we wanted that array to stick around across various function calls. Well, we'll see here that dynamic memory is going to address both of these two kind of wishes. But before we get into that, let's just talk about memory allocation a bit more. So we said we had the stack, which was the allocation of memory to named objects or variables on the stack. We said that the size of variables had to be known at compile time, and that each time you call a function, a new block of memory called an activation record was added to the stack to hold automatic variables. In addition to this, we had the static and code region of memory, where essentially the allocation of memories for variables declared as static or global would reside. And now finally, getting into the topic for today is the free store. And what we said here is that this is where dynamically allocated objects would reside. Moreover, that the size of these objects could be unknown at compile time, and that we could request memory for these objects at runtime, so as our program is running. So with that in mind, let's go ahead and transition into dynamically allocated objects and figure out how we can request an object that resides on the free store, as well as what we have to do when we're finished with it.